Alrighty, guys, we're on 4.4, Intro to Related Rates. And thing with related rates to understand, which I kind of got into 4.3, is that many variables, they have some kind of relationship. They're all related to each other in one way or another, and there isn't really notes for this, but through these problems, we're going to see how we can find different ways to relate um, certain variables and numbers to each other. So we have here, and I have this drawing here for my notes. A police car approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. Set up a relationship, then find an equation that shows the related rates of the vehicles with respect to time. Alrighty. So, based over here, I would say first step you got to do. Alright, step number 1, draw a picture. I'm sure this is a sign. 1, draw a picture. It's going to help you so much more visually, especially for those. It's very easy to mix things up in your head, but when you see it on paper, it makes more sense, alright? And that's exactly what my arrows here are showing. I'm going to switch colors since I already have an orange. The police car, alright, he's turned the corner or the police car is coming, it says from the north, so you understand that he's coming from said point here, and he's trying to chase said speeding car that is moving straight towards the east, alright? And lucky ducky here, this right here creates a lovely perfect right angle, alright? And of course, and this right here, your distance here, which I have is D for distance, you have your Y and your X over here, is going to give you a perfect right triangle. And because of right triangles, we can use Pythagorean theorem. And that is basically how you can relate this specific set of variables. And that's something you'll see in a lot of other problems. You can use Pythagoras, and it's going to be great. So that's how you got this d squared equals x squared plus y squared, because I know originally it's a squared plus b squared equals c squared. Alrighty. And so with this, you're basically able to do whatever you want to it, whatever you need to it. But of course, this is regular. And so the next step is, and then of course, draw pick, find what you're going to use to relate. So find relation. In this case, was Pythagoras. And the next one, you'll see it's a bit different. And sometimes the relation will be given to you. Again, you'll see in a little bit. 3, you're going to derive. Next, you want to derive. You want to take the derivative with respect to time, of course. Respect to time. So we're taking d of dt of x squared plus y squared equals d squared, which of course with taking the derivative of all of these along with chain rule, you're going to get 2x dt. Oh, I forgot to specify this. You're going to be using implicit differentiation when you're deriving for all of this. It's all going to be implicit differentiation. I know with x, you can feel tempted to be like, oh, the derivative of x is going to be 1, or you're going to do 2x. Nope. In this case, you will be using implicit differentiation, which is why chain rule comes into play. Because you have x squared, so you do power rule to get 2x, and then, of course, times dx dt. We're doing that again for the y squared as well, so plus 2y dy dt, and that's going to equal 2d d dt. dt. Yeah, I know. A little crazy there. But that is basically the equation that shows the related rates of the vehicle with respect to time. That'd basically kind of be your final answer. All right? So yeah, that's kind of your steps here. And let me just write implicit. You're going to be doing a lot of implicit differentiation. So if you don't remember how to do that, and of course with implicit comes chain rule. So if you don't remember how to do that, go and do that. Anyway, so now we have a lovely little rectangle. So the width and length of a rectangle are increasing. Relate these rates of change with the rate of change of the area of the rectangle. So again, step 1, we're going to draw us a little picture. Let's do pink. We have a lovely rectangle here. Here's our length and here's our width. Just go on all sides, all right? And it says it wants to find the rate of change specifically of the area of the rectangle. And in this case, the way that we're going to relate our variables is with A equals L times W, because that is exactly what area is, length times width, all right, of a rectangle. And so then, step 2, we're going to derive this. So d over d with respect to time, or anytime it's a rate, just know it's with respect to time. It may not explicitly say so, but again, d dt of L times W. And when you're taking the derivative of things that are multiplied, you're going to use product rule. So let me just write this out. Product rule. And with product rule, you're going to get this. So let's do product rule really quickly. We have length and width. Derivative of length is just going to be dl dt. Derivative of width is going to be dw dt. You multiply and add these puppies. So you literally have dA dt, because that's the change of area over time. dA, let me get a different color for you guys. dA dt is going to be dw dt of L plus dL dt times W. And that's basically your rate of change of the area of the rectangle. And so now that's it for 4.4. But with 4.5, now we're going to basically use what we did here, all of this implicit differentiation, chain rule, all of this jazz, with finding the related rates, and turn that into basically actually solving for something specifically. And we'll get into that. Anyway, see you guys next video.